This video looks at the energy program and setting the plant settings in display options and the effect that has on your calculations. So the energy is found in the mechanical tab. We go into energy and then we need to edit general plant. So first of all, you have your building weight, mechanical ventilation. This will have a bearing on your plant modelling, whether or not your light fittings are off during the day, the building usage, which will have a bearing on the energy consumption, and the calculation basis, whether you're looking at predominantly a radiant system or an air system. That will enable the program to differentiate between radiant calculations and air temperature. So if you're doing predominantly underfloor heating, you might want to refer to dry resultant temperature. Here on the general plant you can see a series of tabs. On the heating side we've got our design outside temperature, so if you're wanting to alter your winter external condition you can do so without recourse to going into the weather database. Mechanical ventilation in brackets winter, this temperature here implies that you are pre-treating the air by another means, i.e. heating the air up from the external condition of -4 up to a supply condition of 10 degrees. That removes the fresh air requirement from the space, so that any heating appliance such as radiators or local fan coil units won't consider the fresh air implication, because you've already treated that air by heating it from -4 to 10 degrees. If you choose to type in 0 here, think of 0 as being O for outside. What we're now doing is venting air in directly into the space from say -4 to your desired room temperature. So for example, if you had an under window air conditioning unit or fan coil unit where the air is ducted directly from outside onto that unit, you want to consider the fresh air requirement to the space. So in which case you would make the entry as 0, and that would then include the fresh air requirement on the local plant. So if you have a mixed system, effectively by entering the 10 degrees here, your air heater battery serving the building supplying the fresh air will handle the fresh air supply, and the remaining heat loss on the spaces when you enter them will be calculated based on the total loss minus the fresh air requirement, which is handled elsewhere. We can also apply a night setback temperature on our system, and also our plant times for our heating season. So we can apply, in this case from October to April, with an on and off time, preheating time, and convective heating correction. Ordinarily, if you're using multi-column radiators, you may want to apply 80% convection. This will look at the F1 and the F2 correction factors involved in section A5 of the guide and apply those accordingly. The same principle applies for cooling. Again, this depicts the fact that we're ventilating air into the building untreated. So whatever the peak temperature is in the weather database for the location we've selected, we are effectively ventilating that air into the space untreated. So any fan coil units or air conditioning units applied to the zones or the spaces will be including fresh air in the separate zones. If I choose now to enter a supply temperature, this now implies that our central plant is handling the fresh air requirement. So we'll have a central plant system with a cooling and chiller unit. That will cool the air from the peak condition from the weather database for the location down to say 13 degrees. Therefore, when we go into each of the zones, the local split system or air conditioning unit we're applying to the space will exclude fresh air, because we've already treated the air on the central plant. Again, you have your cooling season plant times, along with any zone diversities you wish to apply for occupancy. And either you can look on a single month or you can look at the peak 3 months. For the energy consumption calculations, you can apply the efficiencies of the systems. So for example, if you're looking at a boiler, or if you're looking at a domestic situation, you may have a typical combi boiler where 90% efficiency is used. You also have the efficiency of the peripherals such as radiators and ventilation, along with your fuel type with a cost expressed in pounds per kilowatt hour. If you are doing a design where you don't have any heating or cooling, so for example if you're doing a domestic situation where on the cooling side you ordinarily don't have cooling plant, you don't want any potential cooling costs to be added to your cost analysis, so you select the no plant tick box. Therefore only heating will be applied to the space. In the next video we'll look at the effect that these entries make depending on the entries that we make on these tabs.